Hello students. Today's topic is cyclic structure of glucose. The structure first of glucose explains most of its property, but the following reaction and facts could not be explained by this structure. So the first structure that we have already seen here. Now let's study the cyclic structure in detail. Despite having the aldehyde group, glucose does not give skiff taste and it does not form the hydrogen sulfide addition product with sodium hydrogen sulfide. Second, the pentaacetate of glucose does not react with the hydroxyl amine, indicating the absence of free aldehyde group. Third, glucose, glucose is found to exist in two different crystalline form, which are named as a alpha and beta form. The alpha form of glucose, whose melting point is 419 Kelvin, is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while beta form, whose melting point is 423 Kelvin, is obtained by crystallization from hot and saturated aqueous solution of glucose at 371 Kelvin. So here we can clearly see the difference in the temperature for the crystallization of glucose. This behavior could not be explained by open chain structure. Okay, it was proposed that one of the hydroxyl group may add to the aldehyde group and form a cyclic hemiacetal structure. It was found that glucose form a six-member ring in which the hydroxyl group at fifth carbon is involved in the ring formation. So here in alpha D plus glucose and beta D plus glucose, we can see that the hydroxyl group of the fifth carbon is attaching with the first carbon and making a cyclic structure. This explanation, the absence of aldehyde group and also existence of glucose in two form as shown below. These two cyclic forms exist in the equilibrium with open chain structure. The two cyclic hemiacetal form of glucose differ only in the configuration of hydroxyl group at the first carbon. Here we can see that the first carbon, the hydroxyl group in alpha form is on our right hand side, while in beta form, the hydroxyl group on the first carbon is left hand side. So that the first carbon is called the anomeric carbon. Consider here the first carbon is called anomeric carbon. The aldehyde carbon before cyclization. Such isomer, it means the alpha form and beta form are called the anomers. The six-member cyclic structure of glucose is called pyranose structure in analogy with the pyran. Pyran is a cyclic organic compound with one oxygen atom and five carbon atom in the ring. So here is the student. This is the total six-member ring in which five members are carbon and one member of the ring is oxygen. So this structure is called pyran, and on the basis of pyran, the structure of glucose is known as a pyranose structure. Okay. The cyclic structure of glucose is more correctly represented by Howard projection structure as given below. So these two structures belong to the Howard projection. Now students, we are going to study another structure that is based on the fructose. Fructose is an important ketohexose. It is obtained along with the glucose by hydrolysis of disaccharide sucrose. It is a natural monosaccharide found in fruits, honey, and vegetables. In its pure form, it is used as a sweetener. It is also an important ketohexose. So student, we have a structure of fructose here. Let's study this structure in detail. Fructose also has the molecular formula C6H12O6 as we all know, and on the basis of its reaction it was found to contain a ketonic functional group at the carbon number 2 and 6 carbon in a straight chain as in case of glucose. So in fructose, similar as a glucose, 6 carbon is in a continuous chain, but in glucose aldehyde group is present while in fructose ketonic group is present at a second carbon. It belongs to the D series and is a levorotatory compound. It is appropriately written as D minus fructose. Its open chain structure is as shown. It also exists in the 2 cyclic form, which are obtained by the addition of hydroxyl group at 5th carbon to the ketonic group. The ring thus formed is a 5-member ring and is named as a furanose ring. Students, earlier we have seen the 6-member ring in which there are 5 carbon and 1 oxygen. Same like that, it is a furan ring. Total 5 member will be there, among which 4 will be the carbon and 1 will be the oxygen. So on the basis of the furan ring, the name is given as a furanose. Okay, so it's a 5-member ring named as a furanose with analogy to the compound furan. Furan is a 5-member cyclic compound with 1 oxygen and 4 carbon atom. So here we have a alpha form and beta form of fructafuranose. The cyclic structure of 2 anomers of fructose are represented by Howard structure. So students, this is the Howard structure of glucose and these are the Howard structure of fructose. You must have to remember both the structures.